When an implication is true, it must be that if the hypothesis is true, then the conclusion is also true. Now, we can represent a statement, P, being true or being false, using a picture as follows. So notice in my top picture here, I have placed a point inside the circle P. When the point is inside the circle P, pictorially we can say that this is representing the statement that P is true. If instead the picture is drawn such that the point lies outside of P, then pictorially this is representing the statement that P is false. Visualizing statements being true or false in terms of whether or not we are placing a point inside or outside the circle can help us try to understand alternative ways that we can phrase the statement if P, then Q. So one of the ways that we can rephrase an if-then statement is we can say that the conclusion is necessary for the hypothesis. Another way you might phrase this is, it is necessary that the conclusion be true when the hypothesis is true. Now, we were just saying that we can represent the statement, the hypothesis is true, for example, by placing a point inside our hypothesis circle. Notice that when you place a point inside the hypothesis circle, because that circle lies entirely inside the conclusion circle, it must be that that point also lies inside the conclusion. So in that way, it is necessary that the point that we've drawn is inside the conclusion circle when the point is inside the hypothesis circle, simply because of the subset relationship that we have in our picture. Another way that we can rephrase an if-then statement is to use this word sufficient. And when we use the word sufficient, what we say is that the hypothesis is sufficient for the conclusion. Now here the word sufficient can be taken to mean good enough. So another way of thinking about this statement is that the hypothesis being true is a sufficient condition or a good enough condition to guarantee that the conclusion is true. There may be other conditions under which the conclusion is true, but knowing the hypothesis is true is good enough to guarantee the conclusion is also true. So putting a point inside the hypothesis circle is sufficient or good enough for guaranteeing that that point is also inside the conclusion circle. Because recall, having a point in the conclusion circle means the conclusion is true. But notice I could instead put a point in the outside part of my circle, like this, such that that point is in the conclusion circle, but not in the hypothesis circle. This is a case where the conclusion is still true, even when the hypothesis might be false. Consider the statement, if it is Tuesday, then it is a weekday. Now, if it's Tuesday, we're saying it has to be a weekday, but just because it's not Tuesday doesn't mean it can't be a weekday. So it could be Wednesday, for example. Being Wednesday would be good enough to also guarantee that the conclusion that it's a weekday is true. So in this way, we would say that it being Tuesday is a sufficient condition for guaranteeing that it's a weekday. Alternatively, I could say that it is necessary that it be a weekday in order for it to be Tuesday. For if it was not a weekday, then Tuesday would be off the table as an option.